Good morning, guys. Now that we've come to the end of the topic of chemical analysis, it is important that we summarise and review what we have learnt. So, if you haven't done so already, please complete your retrieval quiz for the lesson on your student worksheet and then come back for the answers. Okay, so let's look at the answers for our retrieval quiz. Make sure you're self-marking your work from home by using the answers from the lesson. It's very fine to make mistakes, that's really good. Okay, however, you must correct them in order to learn from them. So the answers are as follows. Techniques used in chemical analysis that use sophisticated machines is instrumental. Number 2, we use spectroscopy to find the concentration of metal ion in a compound. Number 3, the reason we use instrumental techniques are because they're more accurate, they're quicker, they're more detailed, and they can also give us quantitative data, numerical data. Number 4, copper gives a green colour flame. Potassium gives a lilac colour flame. Number 6, carbon dioxide turns lime water cloudy. Number 7, a pure substance will only produce one spot during chromatography. Number 6, air is a mixture. Number 9, chlorine turns blue litmus paper red, then white. And the challenge, well done if you got this. It said describe why gas chromatography is better than paper chromatography. Well, paper chromatography can only tell us what components are in the mixture, whereas gas chromatography, being an instrumental technique, can tell us the concentration of each component, how much of each component is present. So as I've already said at the start, this whole lesson today is about reviewing what we've learnt in the topic of chemical analysis. Now, I've included all of the vocab throughout this topic today. I haven't included the definitions because we have already learnt them. However, these should all be familiar to you, and nothing should be new. So just to break down the topic, okay, so we've covered all of these lessons 1 to 8. We started off at the very start with gas tests. We looked at pure substances and formulations. We then looked at how to separate a soluble mixture using chromatography. And then we looked at the different tests for the ions, how to test for positive ions, how to test for negative ions. And then our final lesson was the instrumental methods. So what I'm going to focus on today is lesson 4 to 8. Those are the ones that we've just covered that are fresh in our heads, so we're going to review them, secure them in our brains, and then during our 50-minute lesson, we'll look at lesson 1 to 3. So just to recap, I'm going to quickly go through each topic from lesson 4 to lesson 8. I'm going to review and summarise the learning of each lesson. And then after that, I'm going to set you a task to apply what you've learned. So lesson 4 was all about ions. Now, I didn't want to go straight into testing ions without revisiting what ions are. So if you remember, ions are charged particles. They're formed when atoms lose or gain electrons. So if an atom loses electrons, they become positive. Remember, if an atom is neutral and it loses negative electrons, it must become more positive. And remember, positive ions are called cations, and they are all metal ions. Now, if an atom gains electrons, so an atom's neutral, if it gains negative electrons, the particle becomes more negative. So A negative ion, an anion, has gained electrons. Now, if you remember, negative negative ions, anions, are always non-metals. So, for example, we've got a chloride ion, a bromide ion, an iodide ion. Remember, these ions are formed from group 7 elements, which means they are halide ions. We've also got an oxide ion, a non-metal ion. Now, can you remember the name of the OH minus ion found in alkalis? Hydroxide. Well done. And two other ones that we looked at were also a carbonate ion and a sulfate ion. Now remember, negative ions are always non-metals. So that takes us to lesson 5, which was we looked at how to test for positive ions using a flame test. Now, this was relatively quite straightforward. There are 4 steps. Firstly, you heat the wire. Remember, we've got our nichrome loop wire. We heat it to check if it's contaminated. If the flame colour changes, we know that it's contaminated. We dip it in acid to clean it. We then dip the wire into the compound being tested, the ionic soap that we're testing. We then hold the sample in a blue flame in the Bunsen burner and we observe a colour change. So remember, lithium. A lithium ion, Li+, will produce a red flame. A sodium ion will produce a yellow flame. A potassium ion produces a lilac flame. Now make sure you're using the word lilac as opposed to purple. Calcium has a charge of 2 positive, because remember it's in group 2. It loses 2 electrons from the outside shell, so it becomes Ca2+. Now, it gives an orangey red flame. Now, that's how we distinguish the difference between lithium and calcium. If you look at the colours of the flames, you can see lithium is bright red, crimson red, whereas calcium is more of an orangey red. And then copper ion also gives a green flame. Now, there was another way to test for positive ions, and that was using sodium hydroxide solution. So if we had an unknown sample with an ionic compound dissolved in it, add your unknown sample to a test tube, add roughly the same amount of sodium hydroxide, and what you should see is a precipitate forming. Now remember, a precipitate is a solid forming inside of a liquid, and a precipitation reaction happens when 2 solutions are added together and a solid forms, hence the name a precipitate. Now, the colour of the precipitate can tell us what metal ion is in that solution. So, for example, if I've got a blue precipitate, I know that it must contain copper ions, because this blue solid precipitate is actually copper hydroxide. So the hydroxide from the sodium hydroxide solution reacts with the metal ion to form a metal hydroxide. Now you do need to know the colours. So that iron can produce 2 different types of ions. So you've got iron 2+ and you've got iron 3+. Now iron 2+ makes a green precipitate, iron 3+ makes an orangey brown precipitate, copper makes a blue precipitate. Now we've got 3 metals that give the same colour precipitate, a white precipitate: magnesium, calcium and aluminium. So how can we distinguish between those 3 white precipitates? Now, if it's aluminium, what we could do is we could test it by adding an excess amount of sodium hydroxide. Now, aluminium hydroxide, the white precipitate, will actually dissolve when excess sodium hydroxide is added. Now, calcium and magnesium don't. So how can we distinguish between those two white precipitates? Then we revert back to a flame test. Calcium will produce an orangey red flame, and magnesium doesn't produce a flame colour. That took us to testing for negative ions. Now, there were 3 negative ions you needed to know how to test for. That was a carbonate ion, a sulfate ion, and then the 3 halide ions, chloride, bromide, and iodide. Now, testing for a carbonate ion, all you need to do is a carbonate, any compound that contains a carbonate, if acid is added, it should release bubbles, it should release a gas, it should effervesce. And if you bubble that gas through lime water and the lime water turns cloudy, it shows it's carbon dioxide. So a carbonate will always release carbon dioxide gas when acid is added. So carbonate ion, you add acid, you should see bubbling. You should bubble that gas through lime water, and if it's a carbonate ion, the lime water will turn cloudy because of the carbon dioxide gas being released. Now, for a sulfate ion, you use barium chloride to test the sample. Now, if a sulfate ion is present, it reacts with the barium and you get barium sulfate, which is a white precipitate. So a sulfate ion will produce a white precipitate when barium chloride is added, because it forms barium sulfate, which is an insoluble solid. Again, a precipitate reaction. So as you can see in the image, we've got our solution, our unknown sample, we're adding barium chloride and it turns white. Therefore, it must contain sulfate ions. Now, with halide ions, we add silver nitrate and then we observe if a precipitate forms. We look for a solid forming in the solution. Now, when we add silver nitrate to our sample, if the sample gives a white precipitate, we know that it's chloride ions in the sample. If it gives a cream precipitate, we know it's bromide ions in the sample. And if it gives a yellow precipitate, it must be iodide ions in the sample. Now, I remember that because if you look at group 7, you can see that it goes chlorine, bromine, and iodine. As you go down, the colours get darker. So it goes from white to cream to yellow. So finally, in lesson 8, last lesson, we looked at instrumental techniques used in chemical analysis. So instrumental techniques are techniques that use machines to test and analyze substances. Now, they are much more favorable. They're much more favorable in terms of the results and the data that they give, because they can give quantitative data that is quantifiable. It can give you measurements, for example, of concentration. They are more sensitive, so it can identify smaller amounts of a chemical in a substance. So if the amounts are so small, for example, paper chromatography might not be able to identify it, however, gas chromatography would. They're more accurate. So by using a machine, you're actually eliminating human error. And they're faster, so they can produce bigger amounts of data in a smaller amount of time compared to us mere humans. And a key example we looked at an instrumental method was flame spectroscopy. So the human technique would be the flame test, okay, holding your sample in a flame, and it will give us a flame colour. Now, that is qualitative data. It gives us quality results that explain things. It gives us detail. It gives us colour, but it doesn't tell us how much of that metal ion is in the sample. So flame spectroscopy uses what we call a spectroscope, a machine, to measure the wavelength of light emitted from these metal ions. And it will measure that wavelength, and every metal ion has got its own specific wavelength of light. So if you look, you can see on this diagram on the screen, you can see the lines that are produced when certain metal ions give out light. So you can see that we've got the visible light spectrum split up into its individual wavelengths and its colours, and you can see the absorption lines of where they gave out light. Now you can compare this to known spectroscopes, known spectrums. So lithium, you can see this is the spectrum lines produced by lithium ion. You've got sodium spectrum lines and so forth. Now, these are known, these are in a reference book, and once you do your own test, you get a line spectra, which you can then compare to known line spectrums. Okay, and as you can see, this one, we can't see, but it links to calcium. The lines are the same as the lines, spectral lines on calcium. Now remember guys, flame spectroscopy is an instrumental method because it uses machines and it gives quantifiable data. Now, it's more favourable because it's more accurate. It can actually distinguish between different metal ions in a compound, whereas a flame test can't because the colours will mix and it can be difficult to identify. And that's why flame spectroscopy is better than using a flame test in the lab. So that takes us on to your task for today. So follow the link and complete the Seneca tasks assigned. Now, if you have forgotten your password or you're struggling with logging into Seneca, what I would like you to do is watch the video that was uploaded on our Google Classroom stream today, and that would just explain to you how to log into Seneca, how to reset your password if you have forgotten it. And once you've completed your Seneca tasks, I would then like you to complete your consolidation phase on your student worksheet, which is RAG rating. So remember, we do a pre-RAG rate for each topic at the start of the topic. We then RAG rate each learning intention at the end of each lesson, and then we do an end of topic RAG. So for the 4 lessons that we've just revised, I would like you to complete a RAG rating. Okay, so you might highlight the box, the colour that you feel you are, or you might put an initial in the box for the colour you think you are. I'm not worried about how you're filling it in as long as you're completing it. Thank you very much, guys.